Hello, I'm Mr. Goen, and this video is going to go through the expressions and formula unit assessments. That's 1.1 through to 1.4 for the National 5 course. So to start with, you will be given the formula list here, which includes the volume of a sphere. The volume is 4/3 pi r cubed. The volume of a cone, volume is 1/3 pi r squared h. And the volume of a pyramid, volume is 1/3 the area of the base times the height of the pyramid. You won't necessarily need them all, but they could come up in the expressions from formula unit. So to start with, we're going to be looking at outcome 1.1, which is surds and indices and standard form. For that, you will need your calculator for the standard form. So straight off the bat, we're going to start with a simplifying surd. Now for simplifying your surds, remember we need to find the factor that is also a square number. So we're looking for the factors of 32. So we're looking for the one that includes a square number. Our pairs, 1 and 32, 2 and 16, 2 and 16, and 4 and 8, and more than that, and we'll loop back around. So we know we now have our pairs. So we're looking for the largest square number, because you'll notice that we have 4 here, which is a square number, but we also have 16. So if we use the pair that is the largest square number, we can say then that the square root of 32 is equal to the square root of 16 times 2. Now we also know from surds and indices we can separate that. That means that the square root of 16 times the square root of 2 is equal to the square root of 32. And now we can simply simplify that. The square root of 16 is of course 4, and we can multiply that by root 2. And there's our answer. Root 32 is equal to 4 root 2. Question 2 starts off with our simplifying indices. So we have x to the power 6 times x to the power 3 divided by x to the power 5. So to start off using our rules of indices, we have on the top there x to the power 6 plus 3. And when we have a power to x on the bottom, we're going to take that away. We can do this all in one big step. Gives us x to the power of 6 plus 3 is 9, minus 5 is 4. We can do that in multiple steps. We can have, for example, x to the power 6 plus 3 over x to the power 5, which will then give us x to the power 9 minus 5, which is x to the power 4. Looking at the same idea for this next question, part 2, we have 8x cubed times 2x to the power negative 1/3. Now if we convert our x cubed into thirds, we'll have 8x to the power 9/3 times 2x to the power negative 1/3. Now our coefficients can multiply together. 8 times 2 is 16. And now our powers add together, which gives us x to the power 9 over 3 minus 1 over 3. Remember, when we add a negative, it's the same as taking away a positive, which gives us 16x to the power 8 over 3. Question B looks at our standard form. The average distance from planet A to planet B is 6.4 times 10 to the power 9 miles. The average distance from A to planet C is 9.5 times as great as the average distance from planet A to planet B. That's a very wordy way of saying that the distance from A to C is 9.5 times bigger than A to B. Calculate the average distance from planet A to planet C, giving your answer in standard notation, in scientific notation. Well, we know that the distance from A to C is going to be 9.5 times bigger than 6.4 times 10 to the power 9. Now we can put that directly into our calculators. 9.5 times 6.4 times 10 to the power 9. And that comes out, and because of the size of the number, our calculator should spit out straight away 6.08 times 10 to the power 10. And our units there are miles. And that's it for outcome 1.1. Moving on to 1.2, we're going to be looking at expanding brackets, factorizing, and completing the square. Outcome 2 then. Expand and simplify where appropriate. A gives us A brackets 5a minus b. So we can start by either using our arcs to remind us, or remembering that the term outside the bracket is multiplied by each term inside the bracket, which is going to give us a times 5a, which is 5a squared, minus a times b, which is ab. C, we're going to use, for b, we're going to use FOIL. We've got c plus 4 brackets c plus 6. Now FOIL gives us our first, our outside, our inside, and our last. And we can draw our arcs in here. The firsts multiply together, the outers multiply together, the inners multiply together, and the lasts multiply together. So firsts, c times c is c squared. Outers, c times 6 is plus 6c. Inners, 4 times c is plus 4c. And lasts, 4 times 6 is plus 24. Now we simplify because we have c squared plus 6c plus 4c is 10c plus 24. Moving on, we are factorizing now. Our first question, y squared minus 9y. We always look for a common factor first. Common to both terms there is y, so we can take a y outside the bracket. Inside the bracket we'll be left with y minus 9. Can't take that any further, so we move on. For b, we've got a squared minus 16. To start with, there are no common factors. Our next step would be to look for a difference of two squares. Well, what we've got there is a squared minus 4 squared. So we can use our difference of two squares pattern. We know that we're going to have a double bracket with the terms a and 4 in each bracket. And since this is a difference of two squares, we're going to have a positive and a negative. C has 3 terms in it. There's no common factor that we can see, and there's no minuses, which means there's no difference. So we're going to use our trinomials method. What we need to look at then is the third term and its sign, and the middle term and its sign. We know we're going to have double brackets, and we know from our first term and from FOIL that the first term in each bracket multiplies together to give us d squared. Now we can make the move there to put that as d in each bracket. Clean that up a little bit. Now we need to look at the last term. Now FOIL tells us that the last term in each bracket multiplies to give us 12. So we need to look at our factors of 12. We can start with pairs. We've got 1 and 12, 2 and 6, and 3 and 4. Now we need to decide which pair we're going to use, and we can do that by looking at the middle term, at the coefficient of d here. It's positive 8. So we want the pair that multiply together to make 12, but add together to make 8. 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. We are going to use 2 and 6. Since this is all positives, we're going to use d plus 2 and d plus 6. You can have those brackets the other way around, same with our difference of two squares. Next question. This is our completing the square. Two methods we can use for this. So, express x squared plus 6x plus 11 in the form x plus p all squared plus q. Now the first form, the longer form, is comparing coefficients. The first thing we're going to do is we're going to expand this expression here. So we have x plus p all squared plus q. Now if we expand this bracket, we can use the squared bracket shortcut. That gives us x squared plus 2px plus p squared plus q. Now we compare the coefficients. We have the expression x squared plus 6x plus 11. That means that 2px must equal 6x, and that p squared q must equal positive 11. So we can say then that 2p is equal to 6, so p must be equal to 3. And since we know that p is equal to 3, we can say that since p squared plus q equals 11, 9 plus q equals 11, therefore q is equal to 2. And we can now follow this up by rewriting in the form x plus 3 all squared plus 2. The other method we can use is something of a shortcut. It comes from our knowledge of completing the square. When we start with our x squared plus 6x plus 11, we can immediately draw in our bracket that has been squared, and we know it's going to contain x. Now we can look at the x coefficient here, the plus 6, and we know that we're going to multiply it by 2, so we can half this 6. So we can start by saying that we have x plus 3 inside the bracket. Now if I was to break that bracket using the shortcut, I would have x plus 6x plus 9, which we've got our x squared, we've got our 6x's, but now we've got plus 9. So what we need to do is figure out what we have to add to plus 9 to bring it up to this plus 11. We need to add on 2. And so now we know we're going to have x plus 3 all squared, that's this red bit here. And we know that to get it up to the original expression, we need to add 2. If you feel confident, use the shortcut. If you want to compare coefficients, you'll still get the same answer, it just takes a little bit longer. Moving on to the next outcome. Outcome 1.3, algebraic fractions. So this uses all of your knowledge, mostly from surds and indices, also your algebra knowledge and your fractions knowledge. So we want to write 4x plus 3 brackets x minus 1 over x minus 1 all squared in its simplest form. Well, we can use our surds and indices here because we know that that x minus 1 on the top is to the power 1. Okay, in the same way that this bracket here is to the power 1. So what we've got there is 4x plus 3 x minus 1 to the power 1 minus 2. So that gives us 4x plus 3 brackets x minus 1 to the power negative 1. And we know that m to the power negative 1 is equal to 1 over m from our rules of indices, which gives us 4x plus 3 on the top and x minus 1 on the bottom. Now, if you don't want to use the indices method for that, the other way we can look at that is to expand that bottom expression. We have 4x plus 3 on the top and x minus 1 on the top. And on the bottom there, we've got x minus 1 brackets x minus 1. That's the same as all squared. And then we can cancel the terms that are on top and the bottom. We can cancel that one with that one, leaving us with our answer of 4x plus 3 over x minus 1. Which method you use is up to you. Both arrive at the same answer. Question 7 uses our operators. Now we have write the following as a single fraction. A over 5 divided by b over c. Now we know from dividing fractions that we're going to flip this second fraction upside down and then we're going to multiply. So instead of a over 5 divided by b over c, what we've really got is a over 5 times c over b. Now when we multiply the tops together to give us our new numerator, and we multiply the bottoms together to give us our new denominator, which gives us AC over 5b. And that's it as a single fraction. The final outcome, outcome 1.4, the biggest of the outcomes, starts with gradient, then the volume of a sphere, and then our knowledge of arcs and sectors. Now, the gradient question starts here with question 8. Points A and B have the coordinates -9, -2, and 12, 5, respectively. Calculate the gradient of AB. Well, we've got 2 points there, so we can use our gradient formula. M equals y2 minus y1 over x2 minus x1. Our points there are x1, y1 and x2, y2. So it's simply a case of filling in the blanks. So we have 5 minus -9. I'm sorry, -2. Pulled the x coordinate accidentally there. 5 minus -2 over 12 minus -9. Continuing that on, we know that when we take away a negative, it's the same as adding a positive. That gives us 7 over 21, which is 1 over 3. And that's the end of the gradient question. There are no units to gradient. Question 9. Calculate the volume of a sphere with the radius 6.1 centimeters, giving your answer correct to 2 significant figures. So, this is where we would need our formula sheet from the start. And we can look up the volume of a sphere formula, which is V is equal to 4/3 pi r cubed. If you can memorize it, it's worth memorizing. It's one that comes up most of the way through National 5, but you will normally be given it on the formula sheet. So our volume then is 4/3 times pi, and remember to use the pi symbol on your calculator, multiplied by our radius cubed. Now our radius, we can see the point from the center to the outside edge is 6.1, so we have 6.1 cubed. This is simply an exercise of typing into your calculator. If you have a fractions button, you can use it for the 4/3. If not, put brackets and do 4 divided by 3. Then we multiply by pi, and we multiply by 6.1 cubed. Now, our calculator gives us then the answer 950.775 ... and carries on, because pi is irrational, so we are going to carry on. Now, our question asked us specifically for an answer correct to 2 significant figures, which means we need to look at the first significant figure and the second significant figure, and then we need to consider the third. Okay? So our volume then is going to be 950. The 5 is not affected by this 0 at all. We leave the 0 in because otherwise we'd have 95 instead of 950. And our units then are going to be centimeters, because we were working in centimeters, and because it's volume, cubed. There is our answer correct to 2 significant figures. Now the largest question and the final question, question 10. A shop supplies cardboard party hats like the one shown in diagram 1. In diagram 2, the shaded area represents the cardboard used in one of these hats. AB is a minor arc from the circle with center O. The radius of AO is 18 centimeters, and the angle AOB is 155 degrees. A. Calculate the length of the minor arc AB, and B. The shop wants to put tinsel around the base of the hats. They have 80 meters of tinsel in stock. What is the maximum number of hats they can make from 80 meters? Well, let's move down a little bit. We don't need to know all of that. So we'll consider part A first. Calculate the length of the minor arc AB. Well, the minor arc is this section of the circumference. And we know that the circumference formula, C equals pi d. or you might be using c equals 2 pi r. It's really up to you, as long as you remember to use either the radius or the diameter respectively. So, since we are looking for an arc, we want a portion. Now there are 365 degrees in a circle. We are using the portion of 155 degrees. So the length of our arc is going to be 155 divided by 360 multiplied by the circumference, which is pi times, and our diameter is 18 times 2, because our radius is 18, which makes our diameter 36. So we multiply by 36, and again we can pop that into our calculator. That gives us times by pi times by 36 gives us 48.69 centimeters. Remember, we are working in centimeters, and because an arc is the length of the outside edge, it's simply centimeters. Now, I have rounded up to 2 decimal places. You really should put at least one more. 4 dot 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 and then round. So our arc is 48.69 centimeters. I'm sorry about my background there. It seems to have stayed white. Now the shop wants to put tinsel around the base of the hats. They've got 80 meters of tinsel in stock. What's the maximum number of hats that they can make from 80 meters? Well, if they have 80 meters and we need 48.69 centimeters per hat, the number of hats is going to be 80 meters divided by 48.69 centimeters. So we need to remember that 1 meter is 100 centimeters. So 80 meters is going to be 8,000 centimeters divided by 48.69. 8,000 divided by 48.69. That gives us 164.304 dot dot dot, and we want the maximum number of hats. Well, we're not going to have 0.3 of a hat, so we're going to have 164 hats. Now that's all 10 questions of expressions and formula. Thank you very much. Keep an eye out for relationships and applications, and find out more at Mr. Go in Maths.